Hi, I'm Pat McMinn, BC Hydro lineman. Today we're going to go over meter safety socket checks for a 12240 residential service. Before we get started on the meter safety socket check, we'll go over our required PPE. The first thing that we will be needing is our Class 0 rubber gloves. Before using them, we'll want to inspect them for damage. Then make sure they have a valid test date. These ones are July 1st, 2017, so they are valid. We will also need a set of CSA approved safety glasses. I prefer the clear ones for this task. Along with our other PPE, an FR shirt is required, buttoned up, as the top half of the meter base will be energized. Finally, we have our Class E hard hat on. The E stands for electrical. We will not need to have a face shield on for checking the voltage because it's under 250 volts. To do our meter safety socket check, we'll be using the Fluke meter. It is very common in BC Hydro. Before checking voltage, we must be sure our meter is on the right setting, which is AC voltage. It has the squiggly line over top of the V. Now that we have our PPE on and our multimeter properly set for the job, we can perform our voltage checks to ensure we have good voltage to the meter base. In this picture, we have line 1 to neutral and should get 120 volts plus or minus 10%. Now on this picture, we're testing from line 2 to neutral. We should be getting about 120 volts plus or minus 10%. Now in this picture, we're testing line 1 to line 2 and should be getting 240 volts plus or minus 10%. We have now completed our checks to make sure BC Hydro is providing the proper voltage to the customer. In this picture, we are checking for voltage line 3 to neutral and should see 0 volts. If we see voltage on the bottom side, there's either backfeed or diversion, and we know we have a problem. In this picture, we're checking line 4 to neutral and should be getting 0 volts also. To complete our voltage checks, we'll do line 3 to line 4 and we'll have 0 volts like the previous two. Now that we have confirmed good voltage at the meter base, we should check the customer side of the meter base for faults. We do this by switching our meter for checking continuity, which is ohm sign the line to the left of it. To make sure we're on the right setting, we should be able to touch the two probes together and get a ringing sound. When checking for continuity, we check the customer side only. When you check for the top side, you'll get continuity all the way to the windings of the transformer, which is not a fault. However, if we get continuity on the customer side, we will not energize as there's most likely a fault on their side. In this picture, we're checking line 3 to neutral and we should get no continuity. In this picture, we're checking line 4 to neutral. We should get no continuity between the two either. If you were to get continuity, that means you have a hot leg and a neutral that are touching, which is not what you want when you energize. A common fault is simply a sounding nail that goes through the ducting and into the neutral and hot leg at the same time. This happens, you notify the electrician and de-energize the meter base from the pole. Now we'll be doing our final check, which is between L3 and line 4, which is in this picture. We should not get any continuity here. If we do, it could be a fault, but most commonly it is a simple fix, getting the customer to open up their main switch. We will not energize a meter base that has a closed main switch, as we do not know what the customer has left on in the house, and we do not want to be responsible for a fire. That concludes our meter safety socket checks. Thanks for watching my video.